Hello everyone. Welcome to Algebra 2 Notes 1.3 Properties of Real Numbers. We're just going to be talking about different laws that all real numbers adhere to when you're multiplying or adding. In division and in subtraction, the rules don't necessarily apply the same way. So this is always with just addition and subtraction. Now, one thing to remember is that if you're trying to apply one of these laws, like the commutative property, which we'll learn means the order doesn't matter, if you have, say, a number of 7 minus 5, really, you can think of this as 7 plus negative 5. And then you can swap the order around. You can go negative 5 plus 7, and you'll get the same thing. That'll make a little bit more sense as we go through. So to start off, just like I kind of gave you a little sneak peek for, the order is what we're looking for in this blank. So the commutative property states that when adding or multiplying, the order does not matter. And this is the go-to example that I used here, just 7.5 and 3.2. If you add 7.5 to 3.2, you'll get 10.7. And in the same way, when you add 3.2 to 7.5, you'll get 10.7. That's the commutative property. The associative property is similar, but it is different. The associative property states that when adding or multiplying, the grouping does not matter. And that's what we're looking for here. So if you were to group this 4 and 2 together with parentheses, you'd get 8 times 7, and that's going to equal 56. And in the same way over here, if you multiply the 2 and the 7 together first, you get 14. And 4 times 14 is still going to equal 56. So the grouping, when you're just adding or just multiplying, does not matter. If this first symbol here was a plus, then the grouping would absolutely matter. But that's not the case here. If it's just a multiplication or just addition, the grouping does not matter. Moving right along to the identity property. The identity property states that when adding 0 or multiplying by 1, the value is unchanged. And that might seem kind of silly to specify, but it does have more application in higher level mathematics, and we actually even use it on many of these problems. So this is just a kind of quick go-to example. The square root of 5, even though it's irrational, still a real number, multiplied by 1 is going to equal the square root of 5. And just as we're looking at here, 0.35 plus 0 is 0.35. And moving on to the next property here, the inverse property. The inverse property states that, and this one's a little bit more in-depth than the others, so we'll break it out a little bit more. When you add the negative of a real number to itself, the sum will be 0. And that might seem like very wordy language, but that's a pretty straightforward example here. Negative square root of 251 doesn't matter how specific it is, plus the exact same, the square root of 251, is going to equal 0. And when we're looking at it from the angle of multiplication, when you multiply the reciprocal of a real number to itself, the product will be 1. Product is just, of course, the word that we use when we're multiplying two numbers together. So the product of x and y would just be xy, the numbers multiplied together. This is probably the most used property of real numbers in mathematics, and I'll give you an example of that. So if we have 7x plus 2 equals, let's say, 16, the inverse property is what we use to say, well, if we're going to get rid of this 2 here, we'll just add the negative, which is going to be negative 2. But we have to do that to both sides, of course, and that's how we know this cancels out. And then we would get 7x equals 14. And then in the same way, to get rid of this 7, this leading 7 in front of the x, we're going to multiply it by the reciprocal, which is just multiplying by 1/7. And oftentimes we just write that as a division by 7. So over 7 over 7. Oh, I don't know what I did here. That should be a 14. then that's going to give us x equals 2. So the inverse property is, I think, the most used property in all of algebra because it really helps us get things a little bit more simple. I think the second most used property is the distributive property. The distributive property states that when any real numbers, and just as an example here, a, b, and c, then a times the sum of b plus c equals the product of ab plus the product of ac. And that seems really wordy, but that's exactly the same as distributing a 2 in this case. So distributing the 2, we're going to say, well, instead of trying to solve this whole thing first, we'll distribute the 2 to the 7x and the 2 to the 3. And that's going to give us 14x plus 6. And those are definitely going to equal each other. This down here is just a table for you guys. Really, this is something that I would recommend you have pulled up when you're going through the homework for this section because it's a lot of trying to remember what the commutative property stands for, what the inverse property stands for, what's the distributive property, things like that. And I just like writing in little hints. So you might be able to see them. They should be pretty faint there on your paper. But the commutative property, the hint that I use here is order. And you can come up with something else if you think that makes more sense to you. But the commutative property is just that, the order. And again, that's multiplication or division. It does not matter if it's multiplication or division. I'm sorry, multiplication or addition. Now with the associative property, it's just grouping. That's the hint that I use for myself. Grouping is the detail here. And again, if it's all addition or all multiplication, the grouping doesn't matter. If it's multiplication and addition, the grouping absolutely does matter. The identity property is just that unchanged property. If you add 0 to a number or multiply a number by 1, it's not going to change at all. The inverse property is that inverted or getting rid of, canceling out. I just think of it as inverted because that's what you need to do to a number to get either to 1 or to 0. You need to invert the number. And then the distributive property, it's pretty much in the name there, distribute. Distributed. And that's everything. If you have more specific questions for this, please email me or Miss Kavanaugh or talk to us in class. We'll see you guys there.